In this screencast, we're going to explore angle pairs with transversals. So on our instructions, we're just going to create a few random lines, and then we are going to create the transversals. So to create some random lines, let's just go to the line tool and click and drag, and that'll be our first line. And again, the goal here is not to get a line that has zero slope or undefined slope. What we want is just something with some slope to it so we can investigate the angles a little better. So that looks about right to me. And then that'll be our first line. We'll create a second line the same way. But the second line, we want it to be parallel to the first. So I just can't create a random line here. What I will do is I will create a random point. And I'll put it maybe right here is good. Now I will use the parallel line tools located under the line tool. Actually, I'm sorry, the fourth icon, parallel line. You're going to highlight the C, the new point, and then highlight the line, the first line, and that'll make a second line segment. Again, if you want to change the colors here, you can do that. Here, just to distinguish it from the other line, I'll make this one purple. And finally, we're going to do that. And using the point tool again, we'll just create a random point, and then, there we go. And then we will create a parallel line to it using the parallel line tool. So we'll highlight the point, highlight the other line, one of the other. It doesn't matter which one because it'll be parallel to both, and then that'll make a third one. So that'll give us the three parallel lines we need. Now we're going to go ahead and create some transversals here, and I'm going to need some points later on. So I'm just going to go ahead and put some random points here just to identify. Actually, before I do the random points, let's identify each one of these lines. And if you take a look at the window here, the algebra window, you notice, remember an earlier lesson, these are all in standard form. Those are the lines that were just created in standard form. If you like the slope-intercept form better, you can right-click and then get the equation slope-intercept form. That might help you see the properties of the lines a little better. In fact, just by doing the slope-intercept form, it's very obvious to me that they all have the same slope, which is the way we prove lines parallel. This one has a y-intercept of 1.2, this one has negative 1.2, and this one has negative 3.2. If you click on the grid tool, you can see, or the axis tool as well, you can see where those intercepts are. There's the 1.2, there's the negative 1.2, and there's the negative 3.2. That's how it shows up on the screen. So for this activity, we don't need the grid or the axes, so we'll go ahead and hide those again just to keep it a little cleaner. Alright, so now we're ready. Let's go ahead and make the transversals, and I don't want to use these points. I want to leave these points alone, so I'll just slide this over a little bit. A, B, C, and D. A, C, D. And then I'll just create a random line using the line tool. Line through 2 points. And again, I'll start up here somewhere, and I'm just going to have this one cut the other 3 lines going in this direction. No particular direction. I just want to get something that cuts them. And then I'll do, that's called a transversal. It cuts other lines. And then I'll create a second transversal over on this side. And again, same thing, nothing special, just cutting across like that. Okay, so there we go, and those are the lines. And now we have 5 total lines on the screen and a whole bunch of angles. If you look at these angles, there are 4 here, another 4, another 4, so that's 12, and then there's another set of 4s over here. So there's going to be 24 total angles that we're going to measure in this screencast. So before I move on, there are a couple instructions I wanted you to follow. One of them was to label the lines. And right now they're all labeled. If you look at the algebra window, that first line, in fact, let me just change the color of this third line just to make it, I can refer to it in colors, make that a green line. And then I'll go ahead and make this one something I haven't used yet, maybe a red one. Oops, that was my green line. And make this one, make that red. And finally, just to distinguish the lines from one another, we'll just make that one, oh, I don't know. Let's do, well, we already have a black line. Let's do like this brown color. Okay, now we're ready to label the lines, and let's just go ahead and pick a line. Like for example, this line right here is called line A. You can see it over here in the algebra window. This is the equation. The y equals is the equation. The A is the actual name of the line. So I'm going to go ahead and right click on that equation, and then I will rename the line. and I would like to call that line line M. Now we can't use spaces when naming things here, so we'll just use actually lowercase letter for line names, and then you'll notice that put it right here on the screen, line M, and it matches the color. The text matches the color of line. You'll see that in the next one. When I do B, rename B, that's the purple line. Let's call that line N, linen, I guess, if you say it all in one word. And finally, that last one, not the last one, but the green one, we'll rename that line P. And the red line we will call line T, Lynette, I guess. And finally, the brown line, we'll call that line Q. And there we go. We've labeled all our lines, and now there's labels on the screen, so I can refer to them with their descriptions. For example, I can say line P is parallel to line N, which is also parallel to line M. Those three lines are parallel to one another. And then these random lines are transversals. They're cutting it. Now you get some special properties here. When the transversals cut parallel lines, you do get some special properties. So to investigate those properties, we need to find the intersection of every one of these lines. So you could do it freehand, or you can use the intersection tool. If you use the intersection tool, it's much more accurate, and you'll get that point right on the intersection. Right there. A couple more. And those are all the intersecting points. Now I notice in my lesson instructions I'm using specific ones. I just want to make sure they match up. I, J, K, L, M, N. Good. That's what I used on the instructions. E and H are the same. Okay. B's here. Alright, now we're going to create a couple more. Well, before I create the random points, let me just show you. Our goal here is to measure all the angles. There's 24 of them, so go ahead and rip through. Just remember that GeoGebra goes in a clockwise fashion when naming angles or measuring angles. So I'm going to go ahead and start measuring the angles. In clockwise fashion, for this particular angle would be G, L, I can use I or A, it doesn't matter, they're both the same angle. I'll use I here, and that's how I'm going to get this measurement tucked away right here. This will be 73.2 degrees. Okay, and for this activity, let's go ahead and round everything to no places. Just keep this tidy. And then go ahead and we'll go ahead and do the other ones now. So this bottom one here, this angle LMJ is going to have the same measurement as GLI or GLA because the lines are parallel and these angles are in the same position. Those are called corresponding angles. So let's find out if that's true. So if I measure this angle right here, that should be 73 degrees. Oh, I forgot to do my angle tool. Let's try that one more time. So this angle right here should be 73 degrees, and it is, because the lines are parallel, they're in the same position. Those are called corresponding angles. Corresponding angles are congruent when you have a transversal cut parallel lines. And sure enough, that one's congruent as well. Alright, so now let's take a look at this side over here. These two angles will not be the same because you're not dealing with parallel lines anymore. But if you measure this angle right here, EIA, whatever that is, it's 118 in this example, these are obviously different. But this 118 should have the same measurement as this one down here because, again, they're corresponding angles. And we'll get one more down here. This will also be 118 because they're all corresponding angles. Okay, now let's take a look at some other angles. So now we've established corresponding angles are congruent. That's good. That's an important property. Another thing we can do is we can take a look at, let's say, this angle right here below the 73. We know these two are supplementary because they make a line, so they have to add up to 180 degrees. And we know that this one over here is going to be 73 degrees because these two are vertical angles, and vertical angles are always congruent. But there's another property here. If you look at the black line and the green line, those are parallel lines. So if you look inside the parallel lines, that's interior to the lines, interior. And this angle right here and this angle over here are on different sides of the transversal. So these are called alternate interior angles, and alternate interior angles are congruent. So the way to do that, I'm going to need I'm going to need points out here to measure those angles. So I'll just create some random points using the point tool. Just make sure you're sitting on the line, otherwise you'll get bad readings, you'll get incorrect readings. O and P is what I'm using. And now I can go ahead and measure those angles. So now I can go ahead and measure angle, let's see, we're trying to measure this angle here, ILM. So that's going clockwise like that. And so angle measurement, ILM, and that's 107. That's good because 107 must be the answer because these two angles right here make a line. If they make a line, they're supplementary. So that has to be 107. But what I'm trying to focus in now is this one right here is also 107 because these are alternate interior angles. So again, clockwise to measure that angle. O, M, L. And now you know why I needed that O to make that angle. So there's the 107, and sure enough, those are the same measurements. They're called alternate interior angles. And we can go ahead and prove another set. In fact, while we're here, why don't we go ahead and measure this angle right here. This angle now, there's a couple properties going on. I know it's 107 because it's a vertical angle. And I know it's 107 because these two angles make a line. They're angle supplementary angles. These two angles right here, the 107 that I just made, is going to match this one because it is a corresponding angle. It's in the same position. So I will measure that angle, and it should be 107 for all three of those reasons. There's a lot of reasons why that's 107. And then we'll go ahead and measure that. And I went the wrong way, just like I told you not to. So let's try that again. Clockwise, B, L, G. I still get it confused. So there we go, 107. Vertical angles, corresponding angles, supplementary angles. Okay, and in this one right here, it's got to be 73 because it's a vertical angle, alternate interior angles, the 107, and this one's got to be supplementary angles. So again, a lot of reasons why that's 73. Let's go ahead and measure that to make sure. And there you go, that's going to be the 73. Okay, and you get the idea. The one last thing I want to do for this video, you can finish up the other angles on your own. I think you get the idea. But the last one I want to cover is this angle down here. This angle down here is outside. Well, actually, let me use this angle down here, all the way at the bottom, the green line. You could have used the purple line. You notice that inside the green line, this would be the interior, because the purple and the green, this would be the inside of the purple and the green. But it would also be inside the green and inside the black. Those are interior angles. But if I wanted to work with the exterior angles, like for example this angle right here would be outside the green and that's outside the black, I can measure that. Let me measure that angle, and then I'm going to show you that there's another property. Oops. Got to go clockwise. Got to remember that. That's hard to remember, even for me to remember. Got to go clockwise. This will measure this inside angle right here, 73, but if I want to measure that angle, then I have to go K, N, H. And sure enough, that's 107. These are called alternate. They're on opposite sides of the transversal, and they're exterior, so we call those alternate exterior angles. And to wrap up this screencast, if you notice the 107 and the 73, these are both on the inside of the parallel lines, and they're on the same side as the transversal. We call those same side interior angles, and you can look right there, you'll see that they are supplementary. They're not congruent, they add up to 180. So that'll be a good place to stop. You can go ahead and finish up the rest of the lesson, I think, on your own, just by finishing up the angles and making those comparisons.